In the middle of 2015, Brazil was going through an epidemic crisis called the Zika virus. Now, this is caused and transmitted by the Aedes mosquito, an annoying little critter. But in 2016, the World Health Organization finally declared that the epidemic was over, but noted that it's still very significant and a long-term problem. In 2018, researchers here in Thailand want to make sure that Zika virus won't cause another outbreak, or at least find a way to prevent it. But here's the problem. The problem is that mosquitoes are cunningly unpredictable. We cannot tell their behavior in a wide-scale area, let alone a whole country. So, how do we predict something's behavior based on just some parametrics? Well, we put them in a simulation. We were able to shoot two birds with one stone by answering which vector controls the most impact, the number of mosquitoes population or the biting rates, including the correlation between the biting rate and other factors such as temperature. The method of mathematical model consists of many components, including both human and mosquitoes. It goes like this. This is a picture of a schematic model of a Zika virus transmission dynamic. It starts with human, S-E-I-R. The S start with the susceptible human that can be infected when they are bitten. Once they are bitten, they become immediately exposed. Once they become exposed, they transition into the infectious class after the incubation period. Finally, the infected human move to the recovered class after time. Mosquitoes, on the other hand, they enter the susceptible class at a birth rate and die at a natural death rate. If a susceptible mosquito bites an infected human, they become exposed. Vice versa, they will become infectious. It looks simple, right? Well, not exactly, because their relationship dynamics require time-dependent, ordinary differential equations. Starting with the human population, we can see that the rate of change in susceptible human, exposed human, infectious human, recovered human are altered by the force of infection from the mosquitoes to human and the transition rate, which is when human are exposed and become infectious, or when human that became infectious starting to recover and then they gain immunity. Now for the mosquitoes population. The susceptible mosquito, the exposed mosquito, and the infectious mosquitoes are also determined from the infection from human to mosquitoes and the rate at which exposed mosquito become infectious, where N is S plus E plus I together. Mind you, there's also some consideration of the natural birth rate and the natural death rate. Now, before any of that, we need to figure out the forces behind the infection between mosquito to human and human to mosquitoes. It is given by the following parameters. Number of time a mosquito bites human per unit time. Maximum number of mosquito bite a human can support per unit time. The probability of Zika virus transmission from an infectious mosquito to a susceptible human. And last but not least, probability of Zika virus transmission from an infectious human to a susceptible mosquitoes. After comparing the mathematical model with the reported case, we can confirm that they are closely matched with the R-square being at 0.9989. That is very good. The model has predicted that by the end of 2016, the number of infected people would be about approximately 1.2087 million, which is consistent to the other estimated number, although it can be different due to the unreported case. This paper provided valuable insight that the possibility of another outbreak is low due to the decreased number of susceptible human. It also suggests that reducing the mosquito biting rate is more highly efficient and effective than reducing the mosquito population, particularly in an area with a significant seasonal variation due to the climatic factor influencing the transmission dynamic. By the time you have finished this paper, you'll have more understanding of this mathematical model and enhance your knowledge about the Zika virus dynamic and its control measure. I highly recommend you to see it for yourself. Link is in the description. For now, I'll see you when I see you. Thank you.